In this week's Weather Lab, we're having a little Halloween fun and discussing, yes.
Okay, good.
And discussing chemistry.
I like that idea. What,
all right.
You keep those
so
songs to yourself.
last night, Chris, I carved this pumpkin. You like how I carved my pumpkin?
That's actually pretty good. Did Mr. Quick help?
Yes.
What happened here?
Well, that's a scar.
Oh.
It's a scary pumpkin.
So his eye's gone and he's got a scar? I thought you made a mistake. Dawn, be honest. Is that a mistake?
No.
Okay, all right.
But anyway, so what we're going to do is we're going to, you know how you've ever seen a smoking pumpkin? Well, we're going to explain exactly what that is. So we have a little bit of water and we have dry ice and we have a pumpkin. That's it. It's carved. There's nothing in there.
Right.
So we pour the water in there.
All right, you want me to pour some water in there?
Yes,
Okay.
that's warm water. We have warm water.
It's warm water. It's
and one of the cool things
better.
about dry ice, and we picked up a few pounds of this. Ooh, gosh. Woo! Woo! Ah! One of the cool things about dry ice is that it why does it make that weird noise?
Because it doesn't want to go in there.
Anyway, it's like a lobster. Anyway, the cool thing about dry ice that it sublimates. It goes from a solid to a gas in one phase at regular atmospheric pressure, which of course is where we all live.
The water just kind of speeds it up. It'll do it on its own, but yeah, it's a process called sublimation. It goes from solid to gas, unlike water, which will go from solid to liquid to gas in a normal atmosphere. Carbon dioxide, which is what dry ice is, a little bit different. It goes from solid straight to gas in a process called sublimation.
So that's the process that's going on when you have your smoking pumpkin. The other thing that we are explaining is why this pumpkin will glow in the dark, if that actually works.
Pumpkin?
Yeah, well, we're hoping that this pumpkin. Basically, I took a regular pumpkin and I covered it with glue, and then I took zinc sulfite, this chemical compound, and I spread it all over the pumpkin. Well, actually, I did some cutouts first, and then I spread it all over the pumpkin. So let's see what happens.
We're hoping it shows up
in the dark.
It does, but it's just
difficult to see. I can see it. It's cool. My pumpkin, my glue.
Oh, look, you can kind of see it.
You can.
Oh, look, there you go. Look,
Where is it?
Look in that camera or in that monitor.
Oh,
see
yeah.
It?
Wait, let me take his face off. Hold on, because you have to take off. You use tape to make the face.
Believe it or not, this is science, folks.
Yeah. Now, but see, I can't see what I'm doing.
Sometimes ridiculous. But
the only problem with turning the lights off is you can't see what you're doing.
Well, you should use the glow of the pumpkin.
And then I need his nose, too. Where's his nose? Hold on.
You can't see?
I can't see.
You have your glasses on?
Yeah, but it's dark in here, Chris.
There you go. Look at that glow-in-the-dark pumpkin. Look at him go.
He looks fairly happy.
He is a little too happy. Well, unlike his cousin with the big scar on his face.
Well, so the reason it glows in the dark, of course, is because the chemical compound zinc sulfide and the fact that it reacts with light.
So what happens is, if I'm sure everyone's kind of seen what a model of an atom looks like. Well, when light hits zinc sulfide, the little electrons that spin around the nucleus of an atom start to get farther and farther away from the center, and they get real excited and they start moving around. Well, as soon as you take light away from it, they start to slow down and move back towards the center. And what happens is, while they're slowing down and moving back towards the center, they emit energy, which is light. So that's how the zinc sulfide actually, in a sense, absorbs light and then reflects it. The same little glow-in-the-dark stars that people put up on their ceilings to make it look like the solar system, it's the same thing, same process. So a couple of chemical reactions.
Why is he breathing on me? This has been a Wednesday's edition of Weather Lab. We'll be right back.
We'll be right back.